Hey guys, Ms. Michelson here. Today I'm back with the spring final exam review and I'm going over the questions from topic 5. So we're starting with question number 6. Topic 5 is all about radical equations, operations, expressions, solving equations, all of that jazz. So our first one is a simplifying problem. So the first thing that I like to do here is think about what is underneath my radical right now, and I see a number. I see the variable x and I see the variable y. So I'm going to go ahead and actually break that apart into three separate kind of terms. I'm taking the fifth root of negative 243. I'm taking the fifth root of x to the 10th power, and I'm taking the fifth root of y to the 15th. Now, the ones that jump out to me that are going to simplify nice are these last two, which these ones with the variables in them, because I'm just asking myself, how many times does the index divide the exponent? 5 goes into 10 two times, so that simplifies to be x squared. 5 goes into 15 three times, so that is y cubed. Those ones simplified really nicely. Now, this one over here, 5, the fifth root of negative 243, this isn't something that I know off the top of my head. So I'm just going to check in my calculator to see, is that a fifth root? And I'm just going to have to get the fancy radical sign pulled up from Desmos. I think it's at the bottom, if I remember correctly. The fifth root of negative 243. And we get 3. 3 to the fifth power is 243. Who knew? But it's negative. So, wrong review. What I'm going to do is type negative 3 x squared y to the third power in my answer box. And we're moving on to our next one, number 7. Assume that all variables represent real numbers. We are multiplying. We practiced these in class today as well. We are double distributing. 7 radical x times 5 radical x is 35x. 7 radical x times negative 6 is negative 42 radical x. Negative 5 times positive 5 is negative 25 radical x. And negative 5 times negative 6 is positive 30. Now I'm just looking for any like terms that I can add or subtract. Nothing goes with this 35x, but negative 42 minus 25 is negative 67 radical x plus 30 at the end. This is my final answer, what I have to type into my answer box. Kind of long. Plus 30. Awesome. Moving right along. The room next door is being really loud. My next question is asking me to rationalize my denominator. The problem that I see in this division or this fraction is the fact that there's a radical in the denominator, and I'm not allowed to have that. So the way I'm going to get rid of it is by multiplying by the conjugate. And if I multiply by the conjugate of the denominator, I have to do it in the numerator as well. The numerator here, simplification isn't too bad. I just have to distribute that 5. So I'm going to have 5 minus 5 radical 3. That's going to go on the top no matter what. Well, unless it simplifies. But now I need to multiply the denominator. And this is like the last problem we just did. This is a double distribution one. 1 times 1 is 1. 1 times negative 3, or negative radical is 3, is negative radical 3. 3 times 1 is positive radical 3. And then radical 3 times radical 3 is 3, but it was negative. So the reason why we're rationalizing our denominator is because we can't have the radical. We multiply by the conjugate because ultimately the radicals will disappear. They reduce to 0. And then I have 1 minus 3. That equals negative 2. So I'm going to have the negative 2 in my denominator there. And I think Savis is okay with me typing this in as my final answer. But I will double check. Awesome. Easy enough. The minus sign in the denominator was just a little bit weird, but they don't seem to mind. Okay. Now we're going on to question number 9. Use transformations to help ourselves graph this function. This is something that we have been doing all year. The only kind of precursor knowledge that we would need is to know the general shape of a radical function. And it starts at the origin, over 1, up 1, over 4, up 2, because the square root of 4 is 2. It looks something like this. Now, we could always use Desmos to graph this, but I will tell you all that you know how to do this. This plus 4 is attached to my x value. That means I'm moving the shape of this graph left 4. This minus 3 means that I'm moving my function down 3. So I'm looking for something that shifted this way and shifted this way. And the only one, well, actually, it could be A or D. And normally at this point in time, I just guess. That's bad to say, but I know I have multiple attempts at the problem, right? So I normally just guess and do process of elimination there. But I'm treating this like it's my final, and I need to make sure the one that I have is correct. This one is over 1, 2, 3, 4, down 3. That's exactly it. So it's just like being thorough with our problems, I guess, is a good skill to have. Okay, we have 2 more, and I think they're both solving radical equations. Determine whether or not this statement is true or false. The question tells me that negative 11 is a solution to this equation, which means if I plug negative 11 into both cases where I see x, I should get the same outcome on either side of the equal sign. So let's test it out. There's one thing that I see kind of right away that's a red flag to me. Negative 11 plus 10 is negative 1. And I'm thinking, is there a way for me to take the square root of a number and get a negative 1? Put a pin in that. Negative 5 times 11 is negative 55. Plus 56 is going to be the square root of 1 equals negative 1. The square root of 1 is 1. And that is not true. When we plug it in, we just objectively see the 2 sides of my equal sign do not equal to each other. Therefore, our answer is false. All right, our last one here. I'm not good at these drawing tools. Our last one is asking us to solve this equation. We have x. Oh, we have 2 x's in our problem. That's okay. This means more fun for us, right? We have 2 x's in our problem. Eventually, we're going to want to consolidate this down to 1x. But the first thing that I kind of see as my problem is one of the x's is trapped underneath of a radical. So I got to think of ways that I can get something unstuck from a radical. And the opposite of square rooting something is squaring it. So what that does is get rid of my radical on the left-hand side. But it does kind of make my right-hand side a little bit more complicated. X minus 2 squared, I will tell you right now, is not x squared minus 4. It is x minus 2 times x minus 2. And then we have to simplify that by double distributing. X times x is x squared minus 2x minus 2x. Negative 2 times negative 2 is positive 4. This simplifies to be 10 minus 3x equals x squared minus 4x plus 4. And I recognize I have a quadratic equation. I am solving for x. I want one side of my equal side to equal 0. I'm going to add 3x to both sides, so I'm going to get x squared minus x. And I'm going to subtract 10. So this is going to be minus 6. And this one is going to factor us negative 3 and positive 2. X equals positive 3, x equals 2, negative 2 as my answer there. Now, we should check these answers to make sure that they both are solutions like we did in our last problem. So let me check 3. 10 minus 3 times 3, we're taking the square root of that, equals 3 minus 2. 3 times 3 is 9. 10 minus 9 is 1. The square root of 1 is 1. 3 minus 2 is 1. That one works. But if we check negative 2, I have a feeling that this one is not going to work. 10 minus 3 times negative 2 equals negative 2 minus 2. 3 times 2, or negative 3 times negative 2 is 6. So that would be 16 and negative 4. Does the square root of 16 equal negative 4? No, it doesn't. So that one ends up being extraneous. And then we are putting only 3 in our answer box. And then if we go to the next question, we are on our probability questions. So I am going to go ahead and end the video here. If y'all have any questions for me, let me know. But I will see you in the next one.